Assalamualaikum. My name is Anis Marisa binti Muhammad Zaini and my matrix number is 211090894. So today I will be presenting our mini project titled Design of Hybrid System for an Indigenous Village. Before I proceed, let me introduce my group members. This project was done together with Nurul Fatin Nabila binti Supli, Nurul Naziha binti Nazri and Siti Aisyah binti Ahmad Tamizi. Each of us contributed to different part of the project to ensure its success. Let's move to the introduction of hybrid power system, which combines wind and solar energy to generate electricity. This system uses the strengths of both energy sources to provide a stable and reliable power supply. During the day, solar panels capture sunlight and convert it into electricity, making solar energy an efficient and abundant resource when the sun is shining. However, when the sun isn't available, such as at night or during cloudy conditions, wind turbines generate power from the wind. By using both energy sources, the system ensures that electricity is generated continuously. To achieve maximum efficiency, it's important to place the wind turbines in areas with consistent wind and the solar panels in locations with the most sunlight. This strategic placement allows the system to operate effectively, providing a reliable energy supply. In conclusion, a hybrid power system combining solar and wind energy is an ideal solution for sustainable electricity generation, reducing reliance on fossil fuels and ensuring a consistent power supply. Next, I will outline the key objective of designing a hybrid energy system, assessing its performance and evaluating its societal, environmental and sustainability impacts. The first objective is to design a hybrid energy system that combines two renewable energy sources or mixed renewable energy with conventional sources. This system leverages the strengths of both energy types to ensure a stable and reliable power supply, while promoting cleaner renewable resources. Next, we will evaluate the system performance, including its suitability for the specific energy needs of the community, its efficiency in energy production, and its overall reliability. These factors are crucial to ensure that the system can meet energy demands without frequent interruptions or inefficiencies. Another key objective is to analyze the societal and environmental impacts of the system. This includes examining how the hybrid energy system affects energy costs and accessibility for the community, as well as minimizing carbon emissions and reducing ecological disruption. It's essential that the energy system is sustainable and doesn't harm the environment. Finally, we aim to ensure the long-term sustainability and efficiency of the system. This objective focuses on making sure the system remains viable over time, with minimal environmental impact, while continuing to provide clean energy for the future.
Assalamualaikum, my name is Nurul Fatin Nabila binti Subli, my matric number 211090978. Today, I will be explaining about the energy challenges in Kampung Penulangon Ranau and the problem with the current energy sources. Kampung Penulangon is a remote area with no access to the main power grid. This lack of reliable electricity affects daily life, including healthcare, education, and small businesses. Without consistent power, the community struggles to grow and improve. Although there is plenty of solar and wind energy in the area, they have their own problems. Solar energy is not reliable because it depends on the weather, so it doesn't always provide enough power. Wind energy is also inconsistent and not used enough. The current system failed to combine solar and wind energy into a reliable microgrid, which make it difficult to meet the community's energy needs. In summary, Kampung Penulangon face big energy challenges due to its location and the problems with solar and wind energy. There is a need for a better, more reliable energy solution to help the community grow.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Naziha binti Nazri. My number is 211092525. So I will continue with my part for methodology. First, I'll start and then select the type of hybrid energy system. and then design the hybrid energy system. After that, simulation of hybrid system using Homer, then analysis of hybrid energy performance. If can achieve, the result can come out, record the data, and if not, we go to the design hybrid energy system again and simulate of hybrid system using Homer again. And then after record the data, conclusion and end. Next, for the result, first under the production section, we can see that there are two sources of energy generation. The furnace Primo 8.2, one which generate photovoltaic which generate 12,646 kilowatt hour per year, contribute 74.3% of the total energy. Then the Gaia wind 11 kilowatt 133 phase which generate 4,376 kilowatt hour per year, contribute 25.7% of the total energy. This gives us a total energy production of 17,022 kilowatt hour per year. Next, in the consumption section, we observe that the AC primary load consume 12,627 kilowatt hour per year, which account for 100% of the total energy consumption. There are no DC or the variable load in this system. Moving to the quantity section, the system produced 3,809 kilowatt hour of excess electricity, which is 22.4% of total production. The unmet electric load is 1.64 kilowatt hour per year, a very minimal value. Next, the capacity shortage is 12.1 kilowatt hour, indicating a small shortfall in meeting the demand. In terms of system performance, the renewable fraction is 100%, meaning that all the energy is generated from renewable source, solar and wind. The maximum renewable penetration is 2,903%, which indicate the renewable energy contribution relative to the total load. Looking at the monthly electric production graph, we can see that the solar furnace 8.2 in green consistently generate power throughout the year. The wind energy Gaia 11 minus 1 in orange varies across months, contributing more during some months like January and December.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Aisyah binti Ahmad Tanizi and my thesis number is 211092528. And for my part, I will be presenting about the discussions. And today I will be discussing the simulation results of a hybrid renewable energy system that combines solar PV, wind energy and also battery storage. The system generates a total of 70,022 kilowatt hour per year, with solar PV contributing 74% and wind energy providing 25% of the total production. This is sufficient to meet the annual AC primary load of 12,627 kilowatt hour. However, the system also produces an excess of 3,809 kilowatt hour, which also could be optimized through additional storage or grid export. Next, the reliability of the system is impressive. Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Aisyah binti Ahmad Tanizi and my thesis number is 211092528. And for my part, I will be discussing the simulation results of a hybrid renewable energy system that combines solar PV, wind energy and also battery storage. For what have been used for this project is already explained before. So the system generates a total of 70,022 kilowatt hour per year, with solar PV contributing of 74% and wind energy providing 25% of the total production. This is sufficient to meet the annual AC primary load of 12,627 kilowatt per hour. However, the system also produces an excess of 3,809 kilowatt hour, which also could be optimized through additional storage or grid exports. Second, the reliability of the system is impressive with an unmet electric load of just 1.64 kilowatt hour and a capacity shortage of 12.1 kilowatt hour, both of which are negligible. The renewable fraction which is 100%, meaning the system operates entirely on a renewable energy. Next, in terms of cost, the level cost of energy, which is also known as LCOE, is RM11.40 per kilowatt hour, with a total net present cost of RM2,228.529.50 and an annual operating cost of 6,014.556 cents. By looking at the monthly trend, solar production remains consistent while wind energy varies across different months. This hybrid approach effectively balances energy generation and demand, which is also can reduce dependence on a single source. Overall, the system is highly sustainable, but optimizing excess electricity usage could further improve efficiency. Next, I will be presenting about the performance of hybrid PV energy system. First, by combining solar PV and wind energy, it will enhance electricity generation. Wind energy also depends on wind speed and also can be very unpredictable. Solar energy is also will be affected by weather, temperature, and also sunlight availability, which is peak sun hour. By reduces weather-related power fluctuations, it will also ensures continuous energy supply when one source is unavailable, which is between two sources if one is available. By doing that, it will increase system reliability and also stability. Local climate and weather condition also must be considered. And lastly, proper location ensure maximum energy generation efficiency.
Next, I will be discussing the benefits of using sustainable energy sources and how they enhance the quality of life, protect the environment, and support a cleaner future. Sustainability electricity sources such as wind and solar energy improve the quality of life by providing reliable power to communities, particularly those without access to the main power grid. This consistent electricity can greatly impact daily life, improving healthcare, education, and local businesses. Another key benefit is increased energy independence. By using local renewable resources, communities reduce their reliance on costly fossil fuels, which help lower energy costs and support local development. Additionally, renewable energy help lower carbon emissions and harmful pollutants that contribute to global warming and air pollution. Unlike fossil fuel like coal and diesel, which have significant environmental impact, renewable sources minimize this damage. The use of renewable energy also reduces the environmental harm caused by fossil fuel extraction, helping preserve ecosystem and natural resources. This shift to clean energy leads to a healthier environment by reducing air and water pollution, improving public health in the process. Lastly, investing in renewable energy contributes to a sustainable energy future for generations to come. It ensures that future generations will have access to clean renewable energy. Sustainable energy not only enhances quality of life but also benefits the environment by reducing carbon emissions, minimizing environmental damage, and supporting long-term energy independence.
To sum up everything that has been stated, this project successfully designed a hybrid energy system using Homer software, integrating solar and wind to provide a reliable and sustainable power source. This system ensures a stable electricity supply for rural areas, which can significantly improve living standards, support local business, and enhance healthcare and education. Additionally, by utilizing renewable energy, this system helps to reduce greenhouse gas emissions, contributing to a cleaner and more sustainable future. With that, I conclude my presentation. Thank you.